Okay, everybody, here we're going to do this whole page in one fell swoop. All right, so we have potential energy. We're going to start with this one right here, okay? So we have potential energy here, and we can assume everywhere here is the same height. All right, so it says that the potential energy is 30 joules there. Well, if the object is the same height but on a ramp, it does not matter, so the potential energy is 30 there. If the potential energy of this is, if the object's the same height here, it's going to be 30 as well. Okay? If we have 3 steps to go down to the bottom, for this we don't need to be specific with numbers, but we're assuming that it's split into thirds, then you could assume that this would be down here would be 20, this down here would be 10. So this is going to be 20 joules. At the very bottom, just before it hits the ground, the kinetic energy at the bottom should be equal to the potential energy at the top, so that's 30 as well. Okay, let's do the car one. This is the only one that's slightly confusing, I'd say, in this whole thing. So we're going to look at this. It says that the velocity is 30 and the kinetic energy is 10 to the 6. Okay, if you were to double the velocity, well, I want you to notice something. The kinetic energy equation is 1/2 mv squared. So if I have kinetic energy and I have a velocity, if I do 1/2 m and I have a velocity of 1 in here and I square it, I'd get one number. Okay, some type of kinetic energy. Let's ignore the 1/2 and the m. What if I double the velocity? Well, if I double this velocity, if this 1 squared is 1, if I double the velocity, 2 squared is 4. 3 squared is 9. So when I go through this problem, I want you to understand that if you double velocity, you don't double the kinetic energy, you quadruple it. And if you triple the velocity, you don't triple the kinetic energy, you 9-tuple it. I don't know what it is, but 9 times. Okay, so when we answer these questions here, to get the kinetic energy of this problem, we're going to do, this will be 4 times 10 to the 6. And this would be 9 times 10 to the 6. Okay, because this was, 2 times the velocity, and this was 3 times the velocity. Okay, but if you double something, you got 4 times bigger. Triple it, you get 9 times bigger. Okay, potential energy here, transferred to work, energy gets conserved, so you can just say 10 to the 4 here. All right, move along here. We got PE, total energy. Always has to add up the same number. So the total here is 15,000. Okay, everywhere else it has to add up to 15,000. So if I have this spot here, well, I can just do 15,000 minus 11250, and I get 3750. 7,500 plus 7,500 equals 15,000. And then rinse and repeat. This will be a 11250 and 15,000 because they all have to add up to the same amount. All right, same thing. The total here is 50. 0 plus 50 equals 25 plus 25 and 50 plus 0. And down below, hopefully you're getting the idea of it. Total always has to equal total. So if the total here is 10, 2 plus 8 is 10. 0 plus 10 is 10, and this has the same height as that. So it's saying this is 10 and that's 0. There you go. Thank you, everybody.